Hello everyone, and welcome to my droidCon Apac session. Hope you're all well and keeping healthy. For the next 20 minutes or so, I'd like to take you on a trip around the set of technologies and tools that we use on a daily basis and are critical to the well-being of any team, project, or business. The title for my talk is A Practical Guide to Version Control for Mobile Developers. My name is Ardeleanu, and I'm a Developer Relation Manager for a business called Vonage. You might have previously heard of us under a different name, Nexmo. Okay, so let's roll back the years and look at how developers used to manage their code, and more importantly, the changes inside the code. The first attempt was what I call local versioning. Say we had a project very creatively named Project. The backups will simply be multiple copies of a project, saved usually at the end of each day. One would create a copy and place it in the backups folder, and will do the same every single day. Obviously, this is hardly scalable and doesn't take into account any sort of team flows. Next came the systems that try to centralize the responsibility of version control. For the purpose of this talk, I'm going to categorize them under centralized version control systems. They always have a client-server architecture with a single central repository on which clients synchronize. So there is a central server that everybody shares. A client connects to the server in order to check out a complete copy of a project, work on that copy, and then later check in their changes. To avoid conflicts, the server only accepts changes made to the most recent versions of a file, and the server is the only one that has an entire history of a project. Any number of clients can do this, but it's easy to see how problems can occur when two clients are modifying independently and simultaneously the same piece of code. Different ways to mitigate this were created with various levels of success. The first popular version of these systems was created in 1986 under the name of Concurrent Version Systems, or CVS for short, not to be confused with CSV, which stands for comma-separated values, a file format for saving tabulated data. CVS was tracking individual files and was pretty widely used. The second wave of systems happened around the year 2000, and its poster child was Subversion. It had native support for binary files and was trying to bring more safety in by using atomic operations. Another major difference to the previous generation was ability to version directory trees. Both of these systems were open source. Another popular choice was TimCity from JetBrains, which was proprietary and included build management and a continuous integration server. In the contrast to the centralized architectures, other developers went into a different direction, making the process distributed and democratize it to various degrees. There wasn't a central server, but peer-to-peer connections. So let's say you are working on a project. A distributed version control system would store the history of your work locally and exchange information about it directly with another user. And that user can do the same thing with a third party, and there is nothing stopping you from doing that either. Every single actor in this scenario will have a full history of a project, so even if one of them was, say, delete the project from their machine, nothing will be in fact lost. Conflicts are still possible, no system can guarantee that, but there are tools to make solving them easier. Obviously, for the exchange to happen, both parties need to be available and accessible. This might not always be the case, so over time one scenario emerged. One of the actors was designated as the central place that was always accessible. It effectively became the central server. But there was a major distinction here. It does not hold a position of power, but it's merely just another copy of a repository, another player, another actor in the chain. The service that made this scenario popular and is very successful at it is GitHub. So what distributed systems are available? They are generally split into two categories, proprietary and open source. I've added the two most popular for each here. The two most popular open source are Git and Mercurial. Funny enough, both were built as replacements for BitKeeper. Git is built in Perl, C and various shell scripts, while Mercurial is built in Python. Given its popularity, I'm going to illustrate concepts using Git, but they are easily transferable to other systems. In a typical workflow, One will store changes for the project in an incremental fashion. In version control parlance, they are called commits, and they form the history of a project. Each commit contains a message which should be used to inform others of the changes contained inside each commit. Commits get assigned a unique hash that becomes their identifier. For simplicity, we usually use the first 8 characters to refer to a commit. The whole identifier is much longer. Commits form a linear history of a project, and this path is referred to as the main branch. Developers can deviate from this default path and create commits in separate branches. Usually a branch is named after a piece of work it contains. In our example, it is named Feature X. Once the work for a feature has been completed, all changes in the secondary branch can then be merged back into the main branch. If you work as part of a team, this merge process involves creating a pull request that could be reviewed, commented on, or approved by your coworkers. Here is how this looks on GitHub for the Kotlin coroutines project. The screenshot contains the top of a current list of open PRs. In a typical team environment, direct commits to the main branch are not permitted, and contributors must use their own branches to track changes. A common scenario is when changes for feature Y are merged into the main branch, and one would like to bring them into the feature X branch. This process is called rebasing and effectively means moving the based commit from which a branch was started. When we rebase the feature X branch, its starting point moves to the commit we're rebasing from. Usually is the last commit in the origin branch. It's also worth mentioning that there is nothing special about the main branch. It doesn't have any special privileges or permissions. The rebase operation can be performed between any 2 branches. The screenshot to the right shows on the same Kotlin coroutines project the current active branches and the relationships between them. There are times when a certain point in the history of a project needs to be marked as important, for example when it is used to release a new version of a project. This is when tags come in handy. In their simplest form, they are markers to a certain commit. In the list of versions on the right, we can see that the latest version 1.4.2 was released from commit 7223897. There are lots of other features available, and you can read more about them on the Git website. I'm also not going to show you any Git-specific syntax. Most of you are already probably familiar with them, and they're easy to find on the website. Before going into Android-specific best practices, here are a couple of generic ones that apply wherever you use version control. The first one should not surprise anyone: commit often. Make each commit a logical unit by including relevant changes together. Not all current changes can or should be part of a commit. On a similar note, all changes making sense to commit together is a good indication that one is working on a single bug or feature. Each commit should have a descriptive message attached to it. You should aim to make it short but include all the relevant information. Do this for your future self, as there will be a time when you're going to hunt down that change you made a couple of months ago. And this is when Git logs come in handy. Its usefulness is particularly critical to keep on top of changes happening in the project you're part of. I encourage you to read the changes your colleagues are making on a regular basis. It will help you both stay on top of things, as well as spot potential conflicts or collaboration points. The next best practice is a big one: use branches. It will make your work life so much better and help everyone in the team. Branches should be used for everything. You have a bug to fix? Create a branch. A new feature? Yep, a new branch. And to prevent conflicts, rebase as often as possible. It won't prevent all the conflicts, but it will ensure that you're up to date, and if you were to merge your branch to the main branch right now, you won't have any problems in doing so. As a corollary to this, during a branch merge, do squash all the commits in that branch into a single commit with a message that describes all the changes. This is particularly useful for bug branches, where one might experiment with various ways to fix that bug and include feedback from others. The last 2 best practices fall into the project integrity category. First, make sure you run all your tests before each commit. A commit should not leave a project in an unstable state. There are a few cases where this can happen, but should be the exception. And when you merge, you should take advantage of automatic tools to check for the project integrity. These tools can be anything really. At Vonage, we use, among others, spell checkers, branch deployment for reviews, and page redirect checks for web projects. For this, we use GitHub Actions, and you can see lots of them in our public repositories. And I would also want to show you some mobile-specific best practices and tips to help you going forward. First of all, Android Studio comes with Git integration baked right in. You can find lots of options in the menu under VCS and then Git. You can also import projects from Subversion, Git and Mercurial. For this presentation, I've cloned and opened here one of our sample repositories to use as illustration. Secondly, there is a Git panel located at the bottom of your Android Studio window. You can use it to navigate the network graph. Let's say, a commit from this branch. I'm going to let's pick one from, let's say, August. Let's pick this one. You can right-click on the commit and kind of perform a series of actions depending on what you need. Let's say you can copy the revision number if you maybe want to send that in an email to a colleague, or you can check out this particular project of this repository if you want to test what's in that particular commit and how the project looked at that particular point. You can also find the list of changes that particular commit included. For this one, there is only one file that was changed. Right-click on the file and select Show Diff. This is probably one of the most useful views, showing you what changed the commit, both in terms of additions, so the green stuff on the right, you can see quite a few things here being added, and also in terms of deletion, the gray stuff on the left, so this stuff here on the left got deleted. Going back to the list of branches, you can create a new branch by right-clicking on Master and then select New Branch. And this will base the new branch on the master branch. You can use this process with any parent branch, really. You can also check out a remote branch. Let's say you want to know what's happening in this OpenTalk 40557-2. You can right-click on it and select Checkout, and that creates a local branch with the same name as the remote one, and it's actually tracking the remote one. So you can see that there are different things. Actually, this one, the last commit was in April last year. Well, this one, it's in January of this year. Rebasing is also easy from the menu. So let's say you want to add the changes from master to OpenTalk to the one we just created, and we kind of want to rebase it, right? So you can go to VCS and then Git and then click Rebase. And you can select the branch you want to rebase to. You can rebase on a remote one as well. You can see the remotes here. But in this case, we're going to rebase it on the master, right? So if you click on rebase, you'll see that we'll run into some conflicts because we have some changes in our current branch that conflict with new changes in the master branch after this our current branch has been created. So if I start rebasing here, you'll see that I run into some conflicts, and if you click on this merge thing, there are quite a few changes. So you'll have to go in and cherry pick what you want. So I'm going to click cancel on this one, close, and then I'm going to abort it. One other quick thing here, you can see that the current branch that we're working on has this little label. You can always go back to master by just checking out the master like that, and then master is the current branch. And you can delete a branch when you don't have a use for it. One thing you need to be careful is you can't delete the current branch that you have checked out. So you can't delete master here. You can only delete branches that can exist but that are not currently checked out. So to do that, right click on the branch and select delete, and that simply deletes the branch. It will ask you if you want to delete the tracked branch. I don't want in this case, so we have these branches on GitHub. I don't want to delete the tracked one, so you just simply ignore that prompt. And that's it for Android Studio. It's fairly straightforward to actually use the Git integration and to be able to use version control fairly easily. Outside of Android Studio, there are lots of resources you might find useful. We'll start with a GitHub gitignore project, a community-driven collection of gitignore files customized for the needs of different languages, frameworks, IDEs, or operating systems. It includes an Android-specific gitignore, which should be a great starting point if you're building an Android app. You actually get a gitignore file when you create a new project with Android Studio, but I encourage you to replace it with a version from the gitignore project. That version includes all the entries in the generated one and much more with categories and explanations. And if you're using Java but not in the context of Android, you should use the Java gitignore file. There are also some good resources under the Community Java folder. As a side note, the Kotlin gitignore is just a symlink to the Java one. One great use of gitignore is to hide private information that should only exist on your machine, and it is required for the project to work. You already get local.properties included in the Android gitignore, but you should also add any other file that contain private information such as credentials. For example, if you are manually signing your app when you publish it, part of the process you are creating a keystore.properties file, and you should make sure that you never commit that, especially if the project resides in a public repository. There are lots of community resources and projects that you can use to make your life easier. I'm going to show you a couple that fit under the auto version on commit category. The first is a little snippet from Stack Overflow that should be easy to follow and adopt inside your build Gradle file. It works by incrementing the version code based on semantic major and minor versions in order to prevent errors when uploading to Google Play. The second one is a Gradle plugin that generates a version code and version name automatically. There are different ways to configure the version code based on your needs, for example, number of commits so far or the date of the latest commit. And the third is a blog post from ThoughtWorks that shows mobile-specific techniques to automate your semantic versioning using the GitHub continuous integration tools. Although the Fastlane versioning action is only available on the iOS platform, it can be easily implemented via a shell script or even as a Gradle task for Android applications. GitHub Actions is another place where you can find lots of little gems to help with your Android development. I encourage you to have a look and maybe even contribute your own snippets. And that's it from me. Hope you found this useful and discover some new ways to make your development life easier. And if you'd like to know more about Vonage and our APIs, here are a couple of links and email addresses. Our communication APIs transform your customer experience with programmable messaging, voice, video, and more. Thank you so much for your time. Stay safe and happy coding!